Okay, so it's now time for a worked example of a type of question that you're likely to come across when dealing with instantaneous rates of change. Now the question says, by plotting the graph of y equals x squared minus 2, find the instantaneous rate of change where x is equal to 1. So looking for the instantaneous rate of change where x is equal to 1. Now, what does this mean? Well, basically, the first thing we need to do is sketch the graph of y equals x squared minus 2. Now to do that, I'm just going to draw out a quick table of values just to refresh your memory on this and what an x squared graph looks like, or a quadratic. You got your x and your y. We'll sketch between -3 and 3, so -3, -2, -1, 0, 1, 2, and 3. Okay, x squared, let's just do some working out for the first one. Y equals x squared minus 2. You get y is equal to bracket -3 squared minus 2, being -3 squared is 9 minus 2 is equal to 7. Okay, so we get 7 there. For the rest of them, I'll just do it. I'll explain as we go. -2 squared being 4 minus 2 is 2. -1 squared being 1 minus 2 is -1. 0 squared being 0 minus 2 is -2. 1 squared being 1 minus 2 is -1. 2 squared minus 2 is equal to 2. 3 squared minus 2 would be equal to 7. Okay, so what we're going to do now is we're going to plot these points. So you've got -3, 7. So we're going to come across to -3 and go up to the 7 and draw a dot. -2, 2 over to there. -1, 1. 0, -2. 1, 1, 1, -1. 2, 2, and 3, 7. Okay, so what you can see here is a few dots that are forming the shape of a parabola. Alright, so just going to draw this graph. Okay, now obviously my parabola is not perfect, but it's got a fair shape going on there. Now the question actually doesn't ask us just to sketch the graph of the parabola. What it is actually asking us to do is find the instantaneous rate of change where x is equal to 1. Now to do that, what we need to do is we need to find the gradient of the tangent, because remember, of course, when I say rates, you say gradient. Rates. Now the gradient of a tangent is, if I was to continue on this line here, it's touching there, and it would continue on in that path if there was nothing keeping on this track here. So I need to find out the gradient of that line. Now to do that, I need to have 2 points, because to find the gradient you need the 2 points. Remembering m is equal to y2 minus y1 over x2 minus x1. So you need 2 points. Okay, well, how do we find 2 points for the gradient? Now, what I recommend is that you get 2 points really close to x equals 1. So let's just say at x is equal to 0.99 and x is equal to 1.01. Now, of course, I could get even closer than that, but I'll stick with 2 decimal places to start off with. So, x equals 0.99. What we're going to do is substitute that in, so you get y is equal to 0.99 squared minus 2, which would be equal to, I'll just go to the calculator, something that I prepared earlier, and you get 0.99 squared minus 2 is equal to -1.0199. -1.0199. Alright, once again, squaring x squared, squaring 1.01, you get y is equal to 1.01 squared minus 2 is equal to, go back to the one that I prepared earlier, so 1.01 squared minus 2 is -0.9799. -0.9799. Now, these coordinates, of course, are 0.99 and -1.0199. This as a coordinate is 1.01 and -0.9799. Okay, so all I now need to do is substitute this point here and this point here into this equation up here. So we're going to have m is equal to y2 minus y1 over x2 minus x1. Right, just scroll down a little bit. Okay, y2 being this value here, which is equal to negative 0.9799, that's that point here, minus negative 1.0199 over x2, 1.01 minus x1, 0.99. Okay, so let's just put that into the calculator. Okay, so on the calculator it is negative 0.9799 minus negative 1.0199. So that's equal to 0.04 over 1.01 minus 0.99 is equal to 0.02. Okay, which is going to be equal to 4 over 2, which is equal to 2. Therefore, the rate of change at x equals 1 is 2. That is, the gradient of this graph of the tangent at x equals 1 is equal to 2. Okay, so the next graph says find the instantaneous rate of change of y equals x squared at x equals 2 using your calculator. So y equals x squared using your calculator. Okay, so I'll just open up my CAS calculator and we're going to go through the same process, but we're going to do it all on the calculator. So to do this, what we need to do is we need to open up a graphs page. Actually, we'll define the function first of all. So we're going to go menu, actions, define. Alright, we're going to call it f of x. So f bracket x is equal to x squared minus 2. So now what we've done is every time I type in f of x, it knows that we're talking about x squared minus 2. Okay, so first of all we're going to find the coordinates of the y coordinate when x is equal to 2. So to do that, what we just do is we just type in f of 2 and it will come up with our y coordinate being 2. Okay, so when x equals 2, y is also equal to 2. That is the coordinate at 2, 2. Okay, so we're now going to continue on with that with the calculator, and we're now going to open up a graphs page. To do that, of course, you go to the home button, and we're going to go graph, double click. Right, and we want the graph to look similar to what we can see here in our settings. So we're going to go menu, we're going to go window, and we're going to go window settings. Now our x minimum, that is our least smallest x value, is going to be equal to negative 5. Our x maximum will be equal to 5. We'll make our scale go up by 1. Our y minimum value, that went down to negative 3. Our y maximum value goes up to a point of 15. And our y scale will also make it equal to 1. Okay, so you can see here that this graph kind of looks quite similar to what you can see there. Now, we're going to sketch the function first of all. So to do that, we're going to press tab. Okay, so we're just going to sketch the graph of x squared minus 2. So to do that, x squared minus 2. Press enter, and up comes the graph. Now, to find the rate of change at x equals 2, what we can do is this. We just go menu, we go down to analyze graph, and then we're going to go dy dx. Okay, see how it says position down here? What we can do is we can just type in 2 and press enter, and it will tell you the gradient at x equals 2. The rate of change is equal to 4. So at the point 2 to the rate of change is 4. there we go. And that's it.
Alright guys, I hope you enjoyed your lesson on average rates of change and instantaneous rates of change. I know, once again, I sure did. I love teaching you from the comfort of your own couch. It means you're happier, I'm happier, we're all getting along. Okay, so remember guys to tune in for our next lesson on motion graphs, okay? And of course, say hi to your maths teacher for me. Morse, yeah. When I say rates, you say gradient rates. Rates. When I say rates, you... Alright.